Hello everyone, welcome back. Now let's see how to build the model in the Tensorflow. Okay, first thing is that we have the two inputs x and y, or the two actual values which we know, and we need to calculate the values of b and a. Okay, so let's try to build the model now. So first and foremost thing is that since there are the two values, I need to compute that, which are my variables, and x and y are my inputs. So what I will do now is that let me create my linear regression model. Let me create the linear regression model. Let me define the class instead of my user defined function. Let me name it as a regression. This is what my class, and the initial values, I will just mention the initial values or my init user defined function and initial values of self and self.a, which was my initial values. And just try to understand that I need to give the initial values. So the variables are the special functions in the Tensorflow which are basically used for the iteration process. For each and every iteration, if you want to update any values, so then you can define the variables. So first of all, this is my variable, and I just mentioned that the initial value for that is 0. And make sure the data type you are mentioning is tf.float32. Okay, cool. This is my first variable. And let me define my second variable in my case. Self.b is equal to tf.variable and initial value. And let me mention that initial value is 0. Anyway, I'll start with all these values with a 0. And let the gradient descent algorithm do it, all the computations of a and b. And just mention that data type of that variable is tf.float32. Okay, so this is what the initial values of a and b we mention. So if I immediately call the model, and the call function that I'm using in this case is, what I'll get is that you just need to specify the input variable x. So if I'm having the inputs with me, and I can do all this such kind of cases. And try to remember that the input what I am giving, it could be like numpy array, and also can be that in the form of list. And what I need to do in this case is that first I need to convert that into tensors. So convert to tensors of x. And finally, what I need to do is that this is what the operation I have to perform. First thing is that multiplication and the addition operation. So I need to perform this multiplication of operation, tf.multiply. And what are the cases I need to multiply? The self.b, comma, and which is what my tensors, input tensors, you need to multiply. Once I got the multiplication of these two values, then I need to add this value. So tf.add, and what I want to add with self.a, and this is what I need to specify. This is what the equation I'm trying to use now, and which is nothing but my model. So as you can see, tf.add a plus b, and the multiplication of b into x. So this is what my model, and this is what my y estimation. So we are clear, and this is what I just want to return y estimation. Execute it. Yeah, small thing is that first thing is that I need to specify the data type. In this case, it is tf.float32. You just want to specify that. Let me check that is anything I just want to do or not. I think it's fine. Execute it now again. Now let's test our model, which is for my regression, whether it is working correctly or not. So what I will do in this case, model is equal to regression. I'll call this class regression. So I call the class regression, and see, I'm already having the inputs x is already there with me. Let me pass that input x to my model. So model of x, if I specify that, what it is trying to do in this case is that it will convert the tensor and multiply and add with a and b values. So as you can see, obviously all the values what I'll get is 0, since the model.a and model.b all are zeros. So model.a is 0 and also model.b is 0. So obviously, anything multiply with 0 is 0 and add with 0, it will be the what are the value you got. So finally anyway we got the value is 0. So this is what first thing is, first we able to create the model in the class. We will continue in the next lecture by creating the loss function, that is sum of square error.